When we write definitions in mathematics, we can write them as a conditional statement in if-then form, or as its converse. So in the last lesson, we found that it was not always the case that a statement, an if-then statement, was true if its converse was true, but actually this is the case for definitions. So when we do definitions this way, we can write it in if-then form, either as its regular conditional or as its converse. They will both be true. So these are both equivalent statements. Again, this is only going to be true when we have definitions. So a statement and its converse are not necessarily always going to be the same. In this lesson, however, they will be, because we're talking about definitions. So the definition for perpendicular lines is if two lines intersect to form a right angle, so that's a 90-degree angle, then they are perpendicular lines. So we can write this with a converse as well. So we could switch that around. We could say if lines are perpendicular, then they intersect at a right angle. Now I've used a symbol here when I wrote this that you might not have seen yet. It's this symbol right here. It's an upside down T kind of looking thing. That means perpendicular. So I will use that symbol instead of the word perpendicular just because it's easier and faster to write. You're welcome to use that as well. But this means perpendicular. And you can see it kind of looks like two lines that are meeting at a right angle. All right, so then if we want to say that line M is perpendicular to line N, we can write that as M is perpendicular to N. So we can use that symbol. It's actually the symbol that we use kind of like if we say congruent. We're not going to use the word congruent. We'll use the symbol like this. That's the congruent symbol. Similarly, if we're talking about things being perpendicular, we would write it just like that. Also, you'll notice this little box here with those two lines in the picture. If you see that box on the pictures or any picture, that means that those two lines are perpendicular. All right, let's look at whether or not these statements are true. So for part A, line AC is perpendicular to line BD. So that's AC going like this and BD going like this. Well, they've got that box there, so based on the picture we can say yes. Yes, since those meet at a right angle, they are perpendicular. For part B, angle AEB and angle CEB. So AEB is this angle right here. And let's see, angle CEB is this angle right here. It's saying that they form a linear pair. Well, yeah, that's correct. So angles are a linear pair if they are adjacent angles, which means they share a vertex and they share a side. So you can see here this vertex right here and this side here that I just darkened in, those are shared by the two angles. So yes, they are adjacent angles, and they are supplementary as well. So they add up to 180 degrees. If we look at the angle going from here all the way around to here, that is a 180-degree angle. So they are supplementary, and in order to be a linear pair, they need to be adjacent and supplementary. So yes, those angles are a linear pair. Part C, ray EA, so that's the ray starting right here and pointing this way. And then ray EB, that's starting right here and pointing this way. It says that those two rays are opposite rays. All right, so in order to be opposite rays, what we need is we need them to have the same endpoint. So they both end right here at E, that's good. But also in order to be opposite rays, they need to be pointing in exactly opposite directions. Well, these are not pointing in opposite directions. They're pointing at right angles to one another. So they are not opposite rays. If we wanted a ray opposite to, say, the red one, we could do this, that'd be fine. If we wanted a ray opposite to the green one, then we could do that would be an opposite ray. But ray EA and ray EB are not opposite rays. All right, example 2. Some more of this. See if the statements are true or not. So it says angle JMF and angle FMG. So let's look at the angles themselves first. So angle JMF is this angle here. and angle FMG, so starting at F, going through to M and then up to G, those are the two angles that we're looking at. So it says they are supplementary. Well, yeah, that's absolutely true. So starting from here and looking at the angle around to here, that's a 180-degree angle. So a straight line is a 180-degree angle. And so if we put those two angles together, the blue one here and then the green one here, that makes up the 180-degree angle. Put those together, we get a straight line. So yes, they are supplementary. B, point M is the midpoint of segment FH. So the segment from F to H, and we're saying that M here is the midpoint. Well, it looks like it is, but in geometry, we cannot ever make any assumptions based on the picture. There is nothing here that would indicate that M is actually the midpoint. There's nothing on the picture, nothing in the instructions. We don't know anything about this based on the picture. There's no information here that would tell us that M is the midpoint. So even though it kind of looks like it's the midpoint, we cannot say that it's the midpoint because we don't have enough information. There's nothing that tells us that it absolutely unequivocally is the midpoint. It just kind of looks like it is, and that's not good enough. So we cannot say that M is the midpoint. We don't have enough information for that. All right, part C, angle JMF. That's this angle right here. And then angle HMG. So that's starting at H, going to M, and then to G. It says that these are vertical angles. Well, yes, they are. So vertical angles, again, are angles that are across from each other when you have two lines intersecting. So these two angles, the blue one and the green one, they are across from each other at this intersection, so we call those vertical angles. They satisfy that requirement. All right, part D. It says line FH is perpendicular to line JG. So that's just the two lines that you see here. So it's saying these two lines are perpendicular. Well, there's nothing on this picture that would indicate that they actually are perpendicular. You know, we don't have any kind of marking like that would indicate that they're perpendicular. Nothing in the instructions. There's no information here that would indicate that they actually are perpendicular. So we can't say that they are. Okay, so with definitions, we talked about how an if-then statement, a conditional and its converse, are both true for definitions. So when you have this, you can write it as something called a biconditional. So if the conditional goes both ways, if you can say, if two if two lines meet at a right angle, then they are perpendicular. And you can also say, if two lines are perpendicular, then they meet at a right angle. If you can say both of those things and they're both true, we can write this as a biconditional. So bi means two. So this is two conditional statements written as one statement. Okay, so biconditional again is a statement that uses the phrase if and only if. So this is how we're going to indicate that it's a biconditional, that it goes both ways. If and only if. This is often abbreviated IFF, so just if with two F's. So if you write it like that with your biconditional, that's a good way of saying if and only if. Okay, so a valid definition, like we talked about earlier, can be written as a biconditional statement. So again, the definition was if two lines are perpendicular, then they meet at a right angle. Okay, if we want to take the converse of that, we would just take the right angle part and put it first after the if. Take the two lines. Oh, I wrote that completely wrong. Hold on. Okay, so what we're going to do if we want the converse, we would take two lines being perpendicular and put that second, so that's the conclusion, and then the lines meeting at a right angle, that would go first. So the converse, we would take the second part here, meeting at a right angle, and put that after the if, and then we would take the lines being perpendicular and put that after the then. So then since both of these statements are true, the conditional and its converse, we can write them as a biconditional. So what we're going to do for that is we're going to take the two statements, which is that the lines are perpendicular and that the lines meet at a right angle, and we just write those two statements down. Doesn't matter which order we do it in, since we can do it either way. That's the whole point of it here. So you can have either one first, but we just write the two statements down and then put if and only if between them. And there it is written as a biconditional. So again, we could have written this the other way around. We could have said lines meet at a right angle if and only if they are perpendicular. That would have been just fine. Again, the IFF here, that means if and only if. So this is a way of joining these two conditional statements together into one statement. Last thing we're going to do is write example 5 here as a biconditional. So there are two statements. One statement is, if Mary is in theater class, she will be in the fall play. You can think of there being a then right here. There's not one written there, but it may help to think of that as an if then. Same thing over here. If Mary is in the fall play, then she must be taking theater class. So these are the same statement, just switched around. These are converses of each other. So in the first statement, we have the theater class being first after the if, and the fall play being the second after the then. And then in the second statement, they're switched around. So the fall play is first and the theater class is second. So we can write this as a biconditional then. So what we would do is we would just take the two statements, Mary being in theater class and Mary being in the fall play, write the two statements down and put if and only if between them. And let me remind you, it would have been as legitimate to say that Mary is in the fall play if and only if she is in theater class. So you could switch that around and have the if and only if still between them, but just have the first part second and the second part first. Again, the whole point of this biconditional is that you can flip it both ways, and it's true no matter which way you flip it.